All right, let's go to the presentation for today. So we are on the session 3, which is going to be on sun simulation. Basically, we are going to do the sun direct hour simulation and also the thermal comfort simulation for outdoor. Okay, and since last week we had some technical issues where I was not able to show the wind tunnel effect study fully. So I will be touching on that today during the starting, and then after I finish that, I'll be going to the sun simulation. Okay, so here is the agenda, which is the first is wind tunnel effect, and then sun direct hour simulation, and then outdoor thermal comfort simulation. All right, so let's get started. All right, so let me show my Archicad model first. Okay, so here's my wind simulation. I've already run the simulation. I have the results here. So let me just move to massing model, where I will just have the massing model visible here. So here you can see I have created a simple massing model using my morph tool. So this you can see here, this is a morph, and also I have created another building with a hole inside so that I can show the wind passing through this hole, and then it hits the surface of this particular house here, and then it comes out this way. Okay, so we will study that. And on the bottom I have just a simple slab. Maybe you can create mesh and then use the mesh as well. So for the sake of simplicity, I'm using this mesh. And also, if you see here, I've created a simple balcony like structure where a person is reading a newspaper here. Okay, so just to show how the effect of wind happens around this area as well. So I've placed a human being there reading a newspaper. And one tips that I would like to suggest here is to have the minimum number of polygons on your project. So if you run the Grasshopper script for a large number of polygons, it will take a longer time to do the simulation, just like what happened to me last week. So I was not able to show the results of my simulation last week. So I would like to suggest to have a very simple massing model that represents more or less the building structure, and then do the modeling with that. And if in case for cases like the balcony, where you want to have a detailed model, maybe that portion only you can create as a detailed model, and then you can just import or export the geometry into Grasshopper to do the simulation. Whereas the other parts of the building, try to have the uh, polygon count as low as possible. Okay, all right, so here is the building as I showed earlier. So here I've already created my Grasshopper connection. So for establishing this connection, go to File, Interoperability, Grasshopper connection, or you can even get the palette from Windows, Palettes, and Grasshopper connection here. Okay, so once you start, you can click the start connection here, and then if you go inside the Rhino, so you can see here I have my script open already. So you just have to open the Grasshopper script so that it will automatically connect to the Grasshopper. Okay, so in this model, in this Grasshopper script, I have all three simulations. I have the direct sun hour simulation. You can see here, this is the direct sun hour simulation, and I have the simulation for wind tunnel effect. So I have created the turbulence for the wind, and then I have the wind tunnel effect visualization, and also I have the simulation for the outdoor comfort. Okay, so the outdoor comfort simulation is also in the same file itself. So I will show one by one. So I've already run the simulation for all of these. So now I'm just going to adjust the preview of these, and then I'm going to show the results. Okay, so the starting, so you can see here I have the building component here. So let me just minimize this a bit. Okay, so let me close all this tools here, the toolbox. Okay, so I'm just closing all that so that I have enough space to show all my script. Okay, all right, so here is my building. So if I click here, you can see the building that I'm using for the simulation. And also I have the context. So here I have the context, which is the next building. So you can see this is the context. So when I select it, it automatically gets selected inside my Grasshopper and also in Archicad itself. So you can see here, whatever I select from the Grasshopper after I pass the information from here, you can select that and it gets highlighted here inside Archicad as well. Okay, so you will know what exactly which component you are working on. Of course, also similarly, I have my slab. So when I select the slab, so if you want to select the slab for the first time, right? So just have the slab node here and then right click. You need to click set one slab in Archicad. So you will be asked to select the slab here. But for my case, I've already selected. So you can see here it gets highlighted immediately. So whichever I select there, it will get highlighted immediately inside Archicad as well. Okay, so once after I bring in my geometries of all these components, I'm using a deconstruct method. So here I'm deconstructing the morph and then the slab to get my boundary representation, which is the geometry of my components. Like for the morph, the geometry of the morphs, and for the slab is the geometry of the slab itself. Okay, and then you can see here for wind simulation, as I told, I will start with wind simulation. So here is my first node where I'm going to enter the geometry of my model and then I'm going to convert it into a butterfly geometry. So this wind simulation is done by butterfly plugin within Grasshopper, as I showed last week. So let me just show one more time the components that are available under the butterfly. So you can see here I'm choosing the butterfly tab here and I have all the components that are related to butterfly. So it has much more. So it does the CFD simulation. So here I'm going to use the wind simulation using the libraries of CFD and then perform the wind simulation here. Okay, so I've converted my geometry into butterfly geometry. I'm not going to go into details of this, but I'll just explain what exactly the node does, and then we'll see the results. Okay, so once after I convert my geometry to butterfly, I need to pass it inside the tunnel here. So I need to create a wind tunnel. So for that, I need to create the corner points of my wind tunnel using this component, which is butterfly create case from tunnel. Okay, so if I show preview of this and then you can see here when I select it, the corner points get selected. So butterfly has created a tunnel around my building, around my geometry that I have passed inside here. So I'm here passing the geometry and then giving a name here. I will come to the wind vector a little later, but you can see here I'm converting I'm passing my geometry and then I'm creating the vertices of the tunnel here, the 8 vertices of my tunnel. Okay, let me just turn off the preview of this, and then you can see here the next one is to create the tunnel grading, and then following which I'm creating the mesh. Okay, so let me just show the preview of my mesh here. So you can see this is the mesh that I have created, and then this particular uh, points, the wind tunnel, you can see it exactly fits on the corner points of the tunnel that is created, which is a mesh. Okay, and then if I zoom in, you can see that where exactly my building is placed, in that location the mesh will be closely placed. Okay, all right, so let me just turn off the preview of this mesh, and then I'm going to create a mesh around the building itself. So here I have the building geometry. So now I'm going to create the mesh around the building. So here is where your building mesh will be created, hex mix. So I'm going to use this and then I'm going to show it here inside the Rhino. So using this, you can see a mesh has been created around the geometry of the building. Okay, so this mesh has to be as fine as possible for an accurate simulation results. Okay, for now I've just made it 2 by 2. Maybe you can go until 5 by 5. So the larger the number, the finer the mesh will be. Okay, so in order to avoid too much of calculation time, I have just made it 2 by 2. But if you have an accurate mesh created around your geometry, it is good for your simulation, which will be more accurate. Okay, so for me, you can see relatively good mesh has been created around my building, but you can refine this even more with by increasing this global refine level. Okay, All right, so let me just turn off the preview of this. All right, so now let me show the wind vector. So let me show how the wind vector has been created. So for that, as I was telling earlier, we need to get the EPW URL for the location of our project. So for Singapore context, as I told earlier, so you can see here, you can scan this QR code and get the weather URL of your project. So for Singapore location, we have one at Changi and one at Seletar base, and then one at Paya Lebar Air Base. Okay, so you can just copy this URL and then use it inside the Grasshopper script, and then using this no, component, I'm converting this weather URL to EPW file, which I'm importing, and then I'm getting the location of it, the location data in the Grasshopper format or the Ladybug format, and I will have the wind speed, wind direction as well. So I'm going to use this wind speed and wind direction to perform my simulation. So you can see here, I'm taking this wind speed and wind direction here. Um, and I'm going to get only the values from the data there. So the data particularly will have lots of other information, but I'm concerned only about the values. Okay, and then once after you get the values, let me show you on the panel. You can see here, this is the wind data every hour throughout the entire year. Okay, so you can see the speed in meter per second. So I can use any of this or maximum, but in my case I'm just using the first one, or you can use any value here, uh, or you can find the maximum of these values and then apply that on your simulation. Okay, so for me I'm using 3900 900th value, and then I'm using it for simulation. So here you can see I'm passing it through wind speed and wind direction, and then I will get the wind vector. Okay, so I'm passing that wind vector inside here to do the simulation. All right, so the next thing I need to do is to create grid. Okay, so for creating a grid, I need to create a box around the geometry that I have imported for doing the simulation. So I have already done that. Let me turn on the preview of it. So you can see here, this is the geometry that I've created. Sorry, this is the box that I've created inside which the wind tunnel effect will be acted upon. Okay, and then I have a slider here which will generate the number of points inside this box, so that I can find out the wind vector and then the speed of wind in that point, in those points. Okay, so I'm passing these points inside this probes butterfly component, and then I'm getting the grid. Okay, so let me just turn off the preview of this box. Okay, so here and then here you can see here I'm stating the number of times the simulation has to run. So for my case, in order to reduce the resources used, the time taken for the simulation, I've just made it 10, but you can make it 100 or even 1000. Okay, so you can do that. So that's where you are importing, or you're keying in the value of the number of times you want to run the simulation, so that you will get an accurate end, or the most reliable information at the end of the simulation. Okay, so once after you get the grid, I'm going to run the real simulation itself using this butterfly solution component. But before that, I can choose the turbulence of my air. So there are three turbulence model inside butterfly. So here you can see you have a laminar turbulence model. We have less turbulence model, which is large eddy simulation, and then we have RAS turbulence model, which is Reynolds average simulation. Okay, you can use any of these. I have used the RAS for now. If you want to know more about this simulation models, right, so just double click here. You will have the information where you can read more about this particular model, and there is also a video which will show what exactly this turbulence model is all about. Okay, so once after I pass this to the butterfly solution, and then I will get the solution of my simulation, and then let me just show here. So the values that I get here are the, okay, so you can see here the values that I get are the vectors of my uh, the airflow, the vectors of airflow. So this one, I'm going to find out the length of these vectors, and then you can see here I'm finding out the length of these vectors, which represents the speed actually. So if I go here, so you can see there are some cases or some entries where the airspeed is extremely higher. Okay, so there are some cases, so these are some errors in the data that has been recorded on the location where we have got the information of the wind data. So we will just exclude those. So you can see here I'm just filtering here. So in this case I'm just filtering the value if it is more than 300, and ready I'm also filtering the value which is less than 0. Okay, and then I will get the vectors of it, and then if I plot the vector using this gradient component, let me show the preview. So you can see here when I just unselect, yeah, so you can see here I have the wind vector, throughout the tunnel itself. So last time I was showing only on the single plane, but now I've created a turbulence inside here. Okay, let me just move this aside so that I can zoom in a bit. Yeah, so you can see here, so the wind enters inside this hole, and then it comes out outside in this direction, and then it hits the surface here, and then it turns. You can see here it turns this side, and then it goes behind. Okay, so you can see here the wind direction that I have set using the data that we got. Okay, so you can see here this is the wind direction that I choose. So here is where I choose the wind direction and then the wind speed. Okay, so I chose the 3900 value. Okay, so similarly you can choose any value, or you can choose to have the maximum wind speed and then the corresponding direction of it as well. Okay, so let me show the legends of it. So change the preview. So you can see here, depending on the color that I have inside the inside in this arrows. So the red color one shows the wind speed is relatively 3.4 meter per second, which is at the top surface. Okay, if you go further down, it turns to be yellow, which is around 1.72 meter per second. And then on the lower part of the building, the wind speed is much lower, which is around 0.35 or 0 or even 0. Okay, and if you see here, there is a person sitting there, and then there are some wind arrows around that particular person. Okay, and let me try to show one more example of this, which I have run and then I have captured the image. So in this simulation which I ran previously, and I have an image of it, so you can see here the wind is in the opposite direction compared to the one that I showed earlier. And then if I see closer of the image where the person is reading the newspaper, so you can see the wind is in the opposite direction compared to the previous one. So this way you will know where exactly the wind affects. And then let me go back to Archicad, and then I can, as I showed earlier the last time, I have my library which I imported inside as an arrow. Okay, so this is the arrow library that I've imported. And if I go inside the objects tool, you can see this is the arrow. So I need to enter the length of the arrow, the rotation of the arrow, and then the color of it. Okay, so let me just close it here. All right, so if I go back to the grasshopper, so here is where I'm entering the length, radius, the rotation, and then the red, green, and blue colors. Okay, from that it will create the arrows inside the Archicad based on the simulation results. So if I show here, so here are the simulation results that I'm showing, and you can also see here the wind acting upon the person. Okay, and if in case, right, if you want to check the wind inside the buildings or somewhere, we can just use um the cut here, and then I can just move my node here. So you can see here the wind is not going inside the building, but it's just going inside the hole here. Okay, okay, so you can try to do the same inside the grasshopper or rhino, and then you can check the results as well. So let's just create a clipping plane. I want to have a vertical clipping plane, and then I can choose. Okay, so just select the vertical clipping plane and then move it. So you can see here the arrows are acting only on the hole, and then you can see it is coming out and then it goes around the building. And then this is like the top portion is having the higher velocity relative to the lower portions. Okay. All right. So that's it about the wind simulation. So if you guys have any further doubt, please post your questions on the chat window. We'll try to reply to those. I think Chidam is already replying to some of the questions. Thank you, Chidam. All right. So let me just move on to the next simulation. I'm going to turn off the preview of this wind simulation results. And then let me just delete this clipping board so that I have the entire building. All right, so let me just show the sun direct hour simulation. So in this case, we are going to study the number of hours the sun hits the surface of the building or any surface that you select within the given period. Okay, so you can see here I have my building and the neighboring building, which is the context of my building. So you can have multiple buildings around your simulation, around your own building, and then you can perform the simulation based on those buildings around your building. But for this case, I've just chosen one building to this for the sake of simplicity. And then I have a slab here. You can use mesh as well from Archicad. So you can see the mesh tool from Archicad here. Okay, so you can use the mesh here as well. Okay. All right, so let me just change to the massing model and then I will delete the cutting plane. Okay. All right, sorry. All right, yeah. Going back to Rhino and Grasshopper, you can see here, this is my this is the first sun path that I need to generate based on the time period that I have set. Okay, so let me just show preview of this. So you can see here, if I unselect this, you can see this is the relative position of the sun to the building based on the time period that I have given. Okay, so here is the time period, the date and time. So here you can see here I have chosen the month of 8 as the start month and end month, and I'm starting from the first day of August and until the 31st of August. And then you can see I have the starting hour 7 a.m. until like 7 p.m. in the evening. Okay, so this is the relative to the sun. And if in case you can see here, if I change the month to say, for example, if I change this to 2, right? So let me just do that. You will immediately see the sun's position changing on the sun path here. Okay, so I change this to second month entirely. Okay, so you can see the sun is at this position relative to the building at the February month. Okay, so let me just go back to 8. All right. Okay. So here, and also I need to select the center point of the building or any point that you want to run the simulation at. So I have chosen this particular point, which is the center point of the building as the center point of my sun path simulation. And then you can play with this scale. So here, this is the size of this the sun path. So if you have a bigger context or a bigger building, you can just key in the scale here, and then it accordingly will create a bigger sun path for you. Okay, so this is just merely increasing the size of the sun path. So considering the distance from the building and then the sun, the relative position is going to be exactly the same because it's very long distance, so it will not change effectively, but only the size is increased. Okay. All right, so once I've get the results for my sun path, I need to do the sun direct hour simulation study. So here is the component that I've used for the sun direct hours. So here you get the results of your vectors of your sun hitting the building So that I'm passing it again using this, and then I have the geometry of my buildings and then the context, so which I'm passing, and then I can run the simulation. So let me just show the preview of it, and then I want to turn off the preview for all my buildings so that it doesn't interfere with the results. Okay. All right, so that's done. So you can see here we have studied the sun direct hours, and then the portion which is yellow in color has the maximum amount of sun or maximum time of sun hitting that portion, and then if it is blue in color, it shows that the sun is hitting that portion very minimum. So in this case here it's 0. Okay, so now if I change the time period to say to second month, so it will totally change the simulation results as well. Okay, so you can see here the sun happened to change its direction, so relative to the position of the building. So the shadow comes out to be on this side, okay, rather than the on the other side in the other simulation. Okay, so this is sun direct hour simulation. So once the simulation is run, you will have the legend created. So you can see here we have the legend created. So this legends can be brought back inside Archicad using the same method that I showed last week, using the objects that we have created for 4 corner points, and then you'll be able to visualize the results inside Archicad effectively. Okay. All right. So let me move on to the next simulation, which is the outdoor comfort, air comfort simulation. So let me just turn off the preview of this model, and then I turn on the preview of my building itself, and then the contextual building. Okay. All right. So here we last time used the wind speed and wind direction from this component, and then used it on the wind simulation, right? So now we have a lot of information that we need to get from this particular component, which is the EPW component. Okay, so I will be getting the temperature, the dry bulb temperature, which is the temperature in that particular area that we have chosen, and then the relative humidity of that area, and then the wind speed as well, along with the wind direction. So relative to the wind speed, the outdoor thermal air comfort will be changing as well. So I'll show you how it changes. So I'll just remove the wind data and then show the results how it changes. And then we also need the direct normal radiation, and then the diffuse horizontal radiation along with horizontal infrared radiation. Okay, so all this data that we need for outdoor thermal air comfort, you get it from this particular node, and then we can import it inside the human to sky relation. So depending on the location where the human stands, this particular component will calculate the relation to the sky. Okay, so if in case the person is standing under a roof, so the sky relation is very limited. Okay, so in that case, this particular node will automatically get that the information from the model, and then it will calculate the sky to human relation. Okay, so but before that we need to have few other information like the location, the north direction and all. So the north direction, you can enter the angle depending on your project. So for me I've just entered 90 degree, or you can bring this value from Archicad itself, so you can do that. And location, you can get the location from the same node where we get the temperature and then the humidity data along with the radiation data. Okay, so the next is the position of the building and then the context of the building. Okay, so the position, let me show, you can see here, I'll just create a preview. So I'm going to use this particular surface as the position, and then the buildings that we have created as the context. So on this surface, I'm going to see the thermal comfort. Okay. All right, so let me just turn off the preview of it, and then you can see here. Um, I just enter the position and then the context, and then along with that I enter a toggle here, which is the run toggle, with northern location. Okay, so after you get the results, you need to use the fraction body exposure and then the sky exposure into the other component, which is called the outdoor solar MRT, which is the mean radiant temperature, outdoor solar mean radiant temperature. Okay, so inside here we need to enter all the values that we get from here. Okay, so from the EPW, we have the temperature, humidity, and then the radiation. So all the data are entered inside here into this particular component, along with the fracture and sky exposure that we just created using this component just now. So I'm just entering those, and then once that is entered, I have the next component, which is UTCI, which is Universal Thermal Climate Index. So you can see I get the mean radiant temperature, which I'm passing it inside this node, and then the air temperature. So the air temperature again comes from the same node here. So you can see the dry bulb temperature, which is the air temperature. And then we also need the relative humidity and then the wind velocity here. So the relative humidity, again, you can get it from here. The wind velocity you can get from the wind simulation that we just performed earlier. Okay, all right, so you can get that, and then if I run the simulation, I will get the results, and then here I'm using this particular spatial heat map component, and then I'm creating the heat map on the surface that I just showed. Okay, so I'm going to show the preview of it. So you can see here, this is the preview. Here you can see the degree Celsius at that particular point. Okay, so this is actually not the real temperature at that location, but this is the perceived temperature. Okay, perceived temperature is the based on the feeling that we have. Maybe the temperature could be 33 degrees Celsius, but we might feel it something like 35. So these values are perceived temperatures. And then on the surface, so just now I told, right, I have created the surface, and on the surface I have just created some points, and then on each point I've calculated the temperature. Okay, so let me just preview. So you can see here, this is the point. Okay, and on each of these points I have calculated the temperature, which is shown as the legends here using the color coding. Okay, and you can see here the temperature varies from 26 to 28, depending on the time period that you choose actually. So here you can see here I'm using this statistics file component, statistic component, and then I'm getting the extreme cold week. So on the extreme cold week of the year, you will get this particular temperature. And if I change this to extreme hot week, you will see immediately the changes. So it is running the simulation. It just takes few minutes. So you will see the values getting changed immediately after the simulation is over. So you can see here earlier it was 26 to 28, now it is 30 to 33. So during the extreme hot week, the temperature in Singapore is going to be somewhere around this range if the building appears to be somewhere something like this. Okay, on a typical week, you can do the same. Okay, so this will be something like an average throughout the year, which is as a typical week. Yeah, you can see here that on the typical week, it starts from 28 to 30 degrees Celsius. It goes until 30 degree. And if I remove the wind, right, if I remove the wind data, so you can see here, I have my wind data here. So if I remove my wind data on this simulation, you will also see some increase in the temperature. So based on the wind that hits and also on the direction, the temperature will be slightly reduced, or the perceived temperature will be slightly reduced. Okay, so let me just try to remove that. Okay, so you can see here it increased 1 degree Celsius if I remove the wind velocity. So it is also necessary to use the wind data that you have receive from the wind simulation and then pass it on here, so that relatively you'll be able to get exactly or close to accurate values of your perceived temperature. Okay, and again with this legend you will be able to export, or you'll be able to transfer these colors, the legends here, to Archicad, using the components that using the object that we have created earlier. Okay, so I showed that last week. um, Yeah, so one more thing that I wanted to show here is, if you increase the number of points here, right? So here I have given the grid size is 2 by 2. So if you increase the point size here, or if you sorry, if you reduce the grid size, right, so you will have a very smaller grid, and then on that grid you will be able to calculate the temperature. And if you see here, the somewhere in between the building, the temperature is slightly lower than when it is away from the building. So if even if I just hide my buildings, right, so inside the building also the temperature will be much lesser. So let me just hide the buildings here. Yeah, so you can see here, just under the building or inside the building, you can see how the temperature is also inside. Okay, and also this particular point that I showed earlier has a height. Okay, so you can key in the height of the person and then you can enter, or you can do the simulation. So right now if you see here, I have given 1.2. It's like if you change the value here, you'll be able to get a different result. Okay, so depending on the height, the perceived temperature will also change. Okay, all right, so I will go back to the presentation. All right, so with this, we have come to the end of this presentation. If you guys have any question, please feel free to post that on the chat. Do follow us on the social media to know more about our products and services. And we also have a YouTube channel where we upload all our webinar and then the tips and tricks videos. So you can scan the QR code and go to the YouTube channel and watch more videos for more information there. Okay. All right. Thank you guys for listening. So let's open up for Q&A.